Triangle anytime. We have a bunch of ways to solve triangles, okay? And we've been spending since basically since we got back from Christmas break trying to figure out what are all these different ways we can solve out triangles. And what I've done here is I've listed them for you. We're going to use this note sheet. You can use this note sheet on your test. Honestly, this is a good enough thing that you might just want to keep it for all times, maybe even algebra to pre-calc, so that you have kind of a collection of all of this stuff. So the first thing that we can do is we can actually use similar triangles to figure out measurements of sides. Works when any two triangles are similar. So this bottom part right here tells you when to use it. Each one of these has a bottom part. That tells you when. Works when any two triangles are similar. Works when finding the missing side in a right triangle. Works when doing this. Works when doing that. So you have an idea of what to use. So first of all, similar triangles. Same shapes, different sizes. Same shapes, different sizes. What was the rule with the angles?
They're all the same.
Angles are congruent. So you're going to write on your note sheet now these things. Angles are congruent. So if I knew the corresponding spots, if I knew this was 12 degrees, I would know that was 12 degrees. If I knew this was 98 degrees, that would be 98 degrees. Whatever the angles happen to be, the angles are congruent. And then we had a rule about the sides, and the rule about the sides is that sides
Same ratio.
are, and same ratio for us. Flip on me here. Sides are proportional was the word that we used. Proportional. That proportional meant you have equal ratios. So I'm going to put some ratios up here. A, B, C, D, E, F. And I didn't go in the same order on purpose. Don't necessarily assume A will go over D. I mean, you have to figure out what order they're proportional in. But it's not necessarily alphabetical order. In this, A to D, C to F, B to E. A over D equals C over F equals B over E. The one thing you can't do in this is you can't put A over D and then put F over C and say they're equal. That doesn't work. You go small to big, you got to keep going small to big. We did a whole chapter on that, solving similar triangles and cross-multiplying to solve out. Okay, second one, Pythagorean Theorem. Pythagorean Theorem works for finding a missing side in a, big word, right triangle. It's got to be a right triangle. If it's not a right triangle, the Pythagorean Theorem is not usable. Okay, I'll put an A, a B, and a C here. The most common theorem in all of math, a squared plus b squared equals c squared. And I also like writing it as leg squared plus leg squared equals the hypotenuse squared. The two smaller sides squared equals the bigger side squared. Always an option when you have Pythagorean theorem. Now, what do you need to be able to use Pythagorean theorem? Angles? I need a right angle, but I have to have more specifically what?
Two sides.
Two sides. I'd have to have A and C to be able to use this. I'd have to have A and B to be able to use this. Works for finding missing side in a right triangle, parentheses, need two sides. You don't have two sides. Okay, next one we did was 30, 60, 90. And the 45, 45, 90, these special right triangles. Well, they're great. They get you there fast. It only works when these special cases happen. It only works when that's a right angle. It only works when that's a right angle, and that is 30. I'll put 30 there. I'll put the 60 there. Boy, you should know these by heart by now. And the 30, 60, 90, across from the 30 goes x. Across from the 60 goes x. Darn it. Goes x square root 3. Goes 2x. Those are the rules that go with there. You put those right over the top of your triangle and you solve. Over on the 45, 45, 90, again we have a right angle, and it's 45, and it goes x, x, and x square root of 2. You use these when you know it's 45, 45, 90, and more specifically, when you want to get an exact answer. When you use the SOHCAHTOA stuff, when you use the trig stuff, those answers, they come out to be like 5.28. Well, this will give me an exact answer like 2 radical 3 or 4 root 2 or something like that. 2 root 3 over 5, something. It'll give me exact answers. These are nice for that. Very useful, very quick. That's part of your tool belt. That's part of what you can use. And then we got into our SOHCAHTOA, which I even spelled correctly for you. Always should write it at the top of your paper whenever you're doing SOHCAHTOA problems. Say it like a samurai. Hooked on phonics, work for me. SOHCAHTOA. Spell it correctly. If you don't spell it correctly, you get it wrong. Only works for what kind of triangle?
90.
90. That's it. And it works for which angles in the right triangle?
The 2.
All of them except the 90. Let's go with alpha today and omega. Did I see what I did there?
Yeah.
Yes, good stuff. All right, and I'm going to put A, B, and C there. Only works for a right triangle. Only works for the 2 acute angles in a right triangle. Doesn't work for the right angle. You'll be able to do sine of 90 when you get to pre-calc, but right now we're doing the 2 acute angles. So let's let's use omega first. So let's write sine, not sin. The sine of omega equals, so what's opposite? A over hypotenuse? C. A over C. Cosine omega equals adjacent? B over hypotenuse? C. B over C. B over C. And then the tangent of omega is equal to
A over B.
opposite over adjacent, A over B. You guys take this chance right now to do the exact same thing for alpha. Do not look up until you're done. Focus on your paper. I'll do them too. And then once you're done, prepare your answers with what I got for alpha. The last thing I want to mention, when finding angles. Use which special keys? Second function, sine to the -1, cosine to the -1, and tangent to the -1. Those buttons are what you're going to use when you want to get to the angle portion of SOHCAHTOA. Okie dokie, that's all the right triangle stuff. Now, after that, we started talking about, and we only spent a couple days on this, so we're gonna spend some more time on some of the stuff today. But we talked about these 2 cases where what if that triangle comes out and it's not a right triangle? What if it's something else? Well, we have these other methods. I told you you'd be able to check your note sheet. Look it down here. You might even want to highlight it like we did in your big notes packet. ASA, AAS, SSA, SSS, SAS. I told you exactly what to use on your specific triangle in each case. You're going along. You're doing these problems. They're all mixed up. I don't know what to do. So I look at what I'm given, and then I reference where I'm at, and I do that specific formula. The first one, law of sines, is the easy one. Law of sines is the easy one. I'm going to go with the law of sines. I'm going to call this big A, this big B, and this big C. And across from big A is little a, little c, and little b. And the capital is important in this. General convention for using labeling sides is big A and then little a is directly across from it. And then the law of sines was simply the sine of the angle, so capital A over little a, the sine of the angle over the side across from it is equal to the sine of the angle, sine of B over the side across from it, little b, is equal to the sine of the angle, sine of big C over the side across from it, little c. And then after you set it up, well, you cross multiply to solve it out. So you get it all set up and then you do the cross multiplication. Last one was that complex one. This one was the big one. Okay? Last one had a lot going on with it. I'll label very similar. I'll label big A, big B, and big C. Little a, little c, little b. And this one was a law of cosines. And it looked like kind of Pythagorean in form because there was an a squared, a b squared, and a c squared. I won't make you memorize it, especially in geometry. Maybe down the road it's something that you'd want to have memorized. But it simply goes like this. If you're going to find an angle given SSS or SAS, the formula goes a squared equals, now that's little, so that's side, a squared equals b squared plus c squared, b squared plus c squared, and it doesn't matter which side is b or c. It could be b squared and c squared, or b squared and c squared, minus 2 times these two times bc, and now here's where the law of cosines comes in, times the cosine of that angle A right there. And it's a big long formula where you have to plug things in. What off of this triangle is not used in the law of cosines? What two things?
Angle B and angle C.
Yeah, you don't use angle B or angle C in the formula. These two things, they just don't get used. In fact, they won't even be there. It'll give you a side, or it'll ask for a side, and we'll ask you to go through that. Now that's everything in your tool belt up to this point. That's everything triangle-wise in geometry that we talk about to be able to solve out what you're going to have to do. Solve out these story problems, solve out these application problems for doing any triangle anytime. Megs, you can stop it right there. I want that one posted separately.